All right, an open box is to be made by cutting a square from the corners of a 16 by 20 inch sheet of cardboard, folding up the sides. What should be the dimensions of the squares that you cut in order for the box to hold as much as possible? Now, this is very confusing for a lot of people because they're like, what the heck is all of that mean? So, you know what? Let's add this in here. Let's get a nice orange color in there.
Orange color.
All right. So let's move that over. I can't move it, but let's just draw this right here. We got ourselves a box that is 16 inches by 20 inches, right? So it's something like this.
Yeah, how would you draw that?
It's just a box. I mean, it's not a box yet. It's just a flat piece of cardboard that is how long and how wide? 16 by 20. So it looks like I drew this one to be longer. So I'm going to say it's 20 from here to here. You okay with that? And then it's 16 from here to here. You okay so far? Yeah, we haven't done any 3D stuff yet, right? We've only got a flat piece of cardboard.
We're doing 3D stuff?
Now, yeah, we're making a box. So, this isn't in the box. This is just a flat piece of cardboard that we're going to turn into a box with an open top.
A sheet of cardboard.
This is my sheet of cardboard. This is literally a sheet. I'm going to show you how it turns into a box. I will show you how it turns into a box. Hold on to that thought. I know you're worried a little bit, but just hold on to that thought. Okay? So, for this to become a three-dimensional box, they tell us that we need to cut the corners and cut the corners in a square form. So I need to cut this corner here, this corner here, this corner here, and this corner here. When you cut those corners, you can then fold this side right here up, and this side folded up as well, and this side folded up as well, and this side folded up as well. Now, if you're struggling to see it, here's what it would look like, right? You'd have something that has a big side like that, and then you have this part of that box, like that. Now, how does that come out to look like this? This right here would be this side of the box. This part over here would be this side of the box. And the height of the box right here would be what we've cut and folded up right here. So you see this wall right here? When I take this and I fold it up, popping out of this thing, that would be the front side of this. Can you see it yet? So that's what they're talking about.
Well, I knew how like the box was made, but I guess I didn't read it because I was like, why did you make it a box if it says a sheet of?
Yeah, so that's how it turns into a box. This sheet gets turned into a box by us folding these edges right here. Folding that one, folding this one, folding this one, and folding this one. When you fold all of that, folding it up, it makes a box with no top. Okay, so that's what they mean by an open top box. Woo!
I mean, it's an open top box, so it wouldn't be like.
Yeah, so there's nothing on the top. All right. So here's the thing, right? I'm trying to get a box that holds the most as possible, right? Do you know what we use to measure the inside of a three-dimensional shape? Volume. So this box right here that I drew poorly, pretend it was drawn nicely, has a length, right? Has a width, but now it also has a height, doesn't it?
Yeah.
How do you calculate the volume of this said box? Length times width times height. That's it. That's it. Length times width times height. So our job now, we got to figure out how the heck are we going to calculate a relationship between the length, the width, and the height. Because I'll be honest with you, I don't want to take the derivative with 3 different variables. Okay? So help me out here. Let's look at this thing. Originally the box was 20 inches long and 16 inches wide, wasn't it? But my length is not going to be 20, is it? It's not the whole length from here to here, right? It can't be, because what did I have to do to get these corners to? I had to cut these corners. And these corners had to be what shape, by the way?
Square.
They had to be square shaped. So if I cut this direction some amount, this direction has to be the same amount, doesn't it?
Yeah.
And that's what makes this square here, and this. So all these squares are the same, aren't they? How much should I cut them by? Well, that's the problem, isn't it? We don't know how much to cut them by. If I cut them by too much, it'll make the fold-ups a lot higher, won't it? Or narrower. It all depends on how much we cut. So is there something we can use to represent a value for now as a placeholder that we don't know how much to cut it by? X. Yeah, let's go ahead and say I'm going to cut this side by X and this side by X all the way around. I'm going to cut that by X, cut that by X, cut that by X, and cut that by X, won't I? So knowing that I'm cutting by X right here, from here to here is X, and I'm cutting by X from here to here, can somebody tell me what is the measurement of this side then? If this is going to be cut out here and here, what would this be? There's two X's that are being cut out here, right? There's an X here that's being cut out, and there's an X here that's being cut out, isn't there? So there's two X's that I'm removing. But what am I removing it from? 20. That's it. Yeah. So what am I going to write down? It's actually, this whole length down here is actually 20 minus 2x. That's what the length is equal to, 20 minus 2x. Can you see it? It's originally 20. But then in order to cut this to make it foldable, I have to cut an x value. I'm going to make it, so this was the original box, this orange, not box, original sheet, yeah? I'm cutting here and I'm cutting here to make a little square, taking that out, okay? When I take that out over here and I take that over there, I'm taking an x value out of it. That x value could be 2 inches, 1 inches, I don't know yet. But either way, I'm cutting the same amount from both. So it's no longer 20 inches long. It's 20 inches minus the 2 x's that I've cut out of it. Does that make sense? Yeah. No? Yeah? Okay. What about the 16 then? What would this be?
16 minus 2x.
Yeah, this one over here would be equal to 16 minus 2x, won't it? Do you see it? 16 minus 2x. Right? It's terrible. I can't write sideways. Okay. So I've gotten 2 of the 3 here. I don't know if you see this. So my volume equation is technically going to be 20 minus 2x, right? What's the next one? My width is going to be 16 minus 2x. And now I just need something for the height, don't I?
Yeah.
Well, how do I calculate the height of this box when I fold it up? What is that coming from? Yeah, do you see it? If you fold up this tab, it's going to have a height of just x. Whatever I cut into this, when you fold it, it needs to go up that high, right? If I cut it 3 inches deep, it's going to go 3 inches up, right, when you fold along this dotted line here. So what's my h? My h is just going to equal to whatever I cut. I'm going to pause there for a second. This setup, by the way, this setup, no calculus involved at all. I've done nothing that has to deal with calculus. This is literally like algebra stuff.
Yeah.
And all we've done is just seen a representation for the volume based off of us making one cut. You see that? That one cut affects the height of your box. That one cut affects the width of your box. You see it?
Yeah.
So if I cut a certain amount, I have to multiply by 2 and subtract it by 16, because that's how much I'm losing from the width. That one cut affects my length of the box. I'm cutting it twice over here, and I'm taking away from 20. That affects my length of the box. Okay? So what we've essentially done is created a function that will find us the volume if we know how much we cut. That make sense?
Yeah.
Again, no calculus involved whatsoever. What's the question asking for us to do, though? They're asking us to find what should I cut it at, what should the dimensions of the square be, in order for the box to hold as much as possible. When you want to hold something as much as possible, is that the minimum amount that you want to hold or the maximum amount? You're technically looking for a max value, aren't you? Right? You're looking for a max value. All right. I don't know if you realize this, but we've done the first 3 steps of our problem, and none of them has to do with calculus yet. Right? Setting up the equations and getting it as a function of something. I know that I briefly talked about this before, but you should always consider looking at the domain as well. How much can I cut to make this reasonable? Well, I should definitely be cutting more than 0, right? If I don't cut anything, I can't fold it up, it won't be a box. So x should be greater than 0. But I can't cut too much. I can't just go in there and say, I'm going to cut infinity for my x. If I cut infinity, then there just won't be anything there, right? How can you cut anything more than that? What do you think the maximum amount I can cut is for this problem?
20.
Close.
We have to figure that out.
Close. No. You don't have to figure it out, but I'm just something we should discuss. It's not 10. It's not 4. 8. 8. 8 is the most you can cut. So let's focus on this. X is just one side, right? So if I go to this thing that's only 16 inches long, I got to cut from both sides, don't I? If I cut 8 inches on the top and I cut 8 inches on the bottom,
You're cutting the whole thing.
I'm cutting the whole thing. Do you see it? So I can't do that because if I cut the whole thing, I'm going to be folding up. It'll just be a folded piece of cardboard that doesn't make a box. Does that make sense?
Yeah.
So I can't cut 8 inches. I got to cut a little bit less than that. So it has to be between this and this. And I say, well, can't you say the same thing with this 20? And I say, yeah. This one, you could cut 10, up to 10, right?
Oh, but that's
But then you screw over this side because you need to make a what?
A square.
You need to make a square. Anita, you had a question?
no, that was my question.
That was your question. Very, very good. All right, so all this long, hot-winded explanation about this whole thing of like, we've done no calculus yet, right? We're looking at this domain, blah, 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 blah. What's the calculus part for us to find a maximum of a function? Derivative, and set it equal to what?
0.
Yeah, so let's do that real quick. So I don't know about you, but I don't want to do the product rule 3 times, unless you want to. Do you want to do the product rule 3 times?
Yeah.
You can practice that.
No.
Or, hear me out, if I needed to do the derivative, why not just simplify it first and then take the derivative, yeah? How do you simplify something like this? Multiply, distribute. One at a time, please. Don't do it all at once, right? So we're going to do right here, distribute this to this. This is going to be 20 times 16, which is
3,200.
3,200 or 320?
320.
320. 320. What's 20 times negative 2x? That's going to give me negative
Negative
40x.
Yeah.
That's done with the 20. I'm going to distribute this one now. What's 2x times 16? Negative 2x times 16 is going to be
32.
positive or negative?
Negative
Negative 32x. Negative 2x times negative 2x.
4x squared.
Positive 4x squared. This, of course, is still all being multiplied by x outside there.
I'm smart.
Let's clean that up a little bit, yeah, shall we?
Thank you.
Let's
Yeah.
clean that up a little bit. I have
Got
like
brain
terms in
power.
here. I also want to write this with this in the front because, I don't know, I got taught that way.
Negative
4x squared minus 72x plus 320. Is that okay?
Yeah.
Yes?
Is that like not required? Like how like the highest power and the
Not at all. That's a personal preference that has been taught into you. I do it though because it just is easier to organize and easier to work with. Distribute the x, we end up with v is equal to 4x cubed minus 72x squared plus 320. Oh, by the way, I should say, Esther, I say that's not required in my class. But in other classes, some people will say that the answer needs to be written in standard form, and that's when it's highest to lowest.
You know, and they have the right to
Is
say
that a
that.
32?
wanted us to do it like that.
3W? Am I tripping? Is that?
You are reading too much into these things.
Wait,
What is
wait, what are you looking at?
The 30 is 320.
Oh,
Oh, here?
yeah.
Sorry, 320.
Freaking out. I thought it was omega for a second. I was about to.
I mean, we'll get there eventually and have Greek letters in our math. All right.
No, I already do enough with AP Physics. We're good.
So, taking a look at this one, now we can get into the calculus, right? I'm looking for the maximum. Let's take the derivative of this volume. So I'm going to write it as v prime. That's going to equal to what?
12x squared. Anita, you got that?
No, I don't. 144.
Come on, Anita, you got it?
320.
Good. In order for us to find the maximum, we need to find our critical points, and our critical points are going to happen when our derivative is equal to 0 or it does not exist, but this is a nice polynomial. It's always going to exist, isn't it?
Yeah.
So we don't have to worry about that, but let's set that equal to 0. 12x squared minus 144x plus 3,200. Nah, look what you got me doing. 32, I'm sorry, 32, 0. 320 is equal to 0. Now, this is a nice quadratic, right? We can solve this by using the quadratic formula if you want. You can factor it if you want to. You can complete the square if you want to. There's many ways for us to solve this.
I think it's clear.
Technique is up to you.
Technique.
For me, I'd probably reduce this because I see that they're all divisible by 12, I believe.
Yeah.
I don't know about 320. Is 320 divided by 12?
Yeah.
Yeah.
32 divided by 12 is
Not a nice number, but
It's
then you get a
not- it's
remainder.
not a full number.
You could do it by 6.
Yeah, let's do that.
No, it's divisible by 12. I'm just saying that 32 divided by 12 doesn't work, but 320 does, I believe.
It's
No.
2.6.
It doesn't?
Not 26.6.
26.6.
Dang, such a shame. What about 6?
32 divided by 6 is 5.3333333333333.
Oh, doesn't work either? So we're gonna have to
It
go
works
by.
with 4.
What about yeah, I was gonna say 4.
Alright, let's reduce it by 4.
Read my mind.
3x squared minus, what is that gonna be? 144 divided by 4?
It's 36.
36.
Too slow.
Plus,
Plus 80.
plus 80. 3 goes into 3x, 3 goes into 36, but 3 does not go into 80, so that is as reduced as it's gonna get, isn't it?
Yeah. What do we do with, what about the 4?
The 4.
Yeah.
Oh, you
but it's gonna
factored
be
it
by
out?
itself.
Oh, you want it? Okay, we do that.
Low key, we don't care about the 4.
Are you supposed
You
to?
don't have to.
Well, think about it. I'm just gonna divide both sides by 4, right? This is never gonna equal to 0, yeah?
So it
only
doesn't
this is.
exist.
But you can write it. I like canceling it out.
Nah.
If it was an x, I would write it, because you can't just cancel out the x to the other side, because then you're skipping out on x equaling to 0.
Alright.
But if it's just a constant, it's just
Who
constant.
cares?
All right, so we got this new quadratic. You guys don't want to do the quadratic formula?
I kind of do.
No.
All right.
Y'all are whack.
Yeah, let's do
Right, what happened to back when we had to do quadratic
The
formula?
quadratic
No,
formula is a
I
big
literally
difference.
love doing it.
All right, here we go. So we got 3x, and x is going to make 3x squared. If you want to do the x method or the diamond method or whatever methods you learn, they're all different.
I can't do that.
I'm just going to do guess and check.
I never know how to factor.
So, doing it this way, I'm looking at it. What numbers multiply to 3 is just 3 and 1, makes 3x squared. What numbers multiply to 80? There's quite a few factors of 80. There's 1 and 80, 2 and 40. 3 doesn't go into it, but 4 does.
4 and 20.
Yep, 5 goes into it.
5 and 16.
Does
8 and
6?
10.
6 doesn't go into it.
420.
8 and 10.
Yeah, I got 4 and 20.
8 and 10.
Yeah, 8
No,
and 10.
but I think it's, isn't it 4 and 20? No, it's not. I'm so dumb.
Please stop.
No,
We get the joke. Please stop.
no, I didn't mean it like that. It's 2 and 40, right?
What's
You're
up?
lying.
2 and
40?
2. I have it right here. 2 and 40.
No, but that's why, isn't it?
Oh, you're telling me the answer.
No, it's not. No? Settle down. Wait, sit down.
Okay, you're jumping ahead. That's what you're doing. You're trying to solve it.
Wait, so it has to.
Alright.
Wait.
Oh, I don't-
It has to add up to 36x, but.
But-
But it's negative 36, that's why, so if,
Oh, this is ghetto. Okay.
Yeah, so they're both going to be negative, right? And the reason why it's not 4 and 20, by the way, or 2 and
Yeah.
40, because you got to multiply one of those numbers by 3.
yeah.
And I'm going to tell you right now, I don't think this is factorable.
I don't think it is either.
Yeah.
Quadratic
Yeah, it's
formula.
not-
I told you.
Why are you talking before I wrote it down?
Let me set it up.
So,
I don't have my
Let me set it
iPad
up.
today.
not factorable. That's a shame. We tried.
We leave it as
We did
it
it
is.
Do you
on
know?
purpose.
Do you know what always works though when it's a quadratic?
No.
Quadratic.
The quadratic formula. Or better yet, can you go
B
grab?
squared minus
Let's.
4AC.
So no, don't write it down. I don't want you to practice that. This is gonna take forever. Which is something that you can do on the AP exam when you don't have a calculator. Let's today practice using your TI calculator. So can you please go grab a TI calculator from the back, or if you have one, pull one out. I'm gonna show you how to solve this using a TI calculator. Because we do have sections where it's calculator available. Why not practice it?
No, I know what it is. Calculator.
Is the test, like, do the majority of the questions are catered to calculator or?
Half are a calculator, half are non-calculator. For both multiple choice and, well, okay, that's a lie. That's a lie. Multiple choice section, I believe it's almost half calculator, and the other half is not. But on the free response questions, 2 calculator, 4 non-calculator. The non-calculators are better one problems because usually those numbers are nice.
Do they supply this or do you
You bring your own. And if you don't have your own, I'm trying to talk to admin so that we have a set that you can borrow if you don't have a calculator, okay? Okay, so let's look at this problem. How do you solve any equation equal to 0 using a graphing calculator? Yeah, we press buttons, that's right. But particularly, y equals is to help us with the function. Now you'll say, knock me, this isn't a y function, it's a v function. I'll say, get over it. It's just a label, right? So we're going to plug in these functions into here. So first things first, what you want to do is press the on button to turn on your calculator.
Wow.
Yeah, that was
That's such a big revelation.
No,
Bro,
honestly,
thank you for helping me. I was struggling
Yeah.
so much.
You joke, but
no, it's true.
It
I
happens.
did it like
all right. Now, I can't just go ahead and start plugging in this equation, 3x squared like this. This does nothing for me. I push this, I press enter, the calculator, I don't know what you want me to do with this. So you need to tell it that this is a function, so we go to our function button right here, which is y equals, right? That's where we get to type in our functions. So y equals, or you'll notice they have little subscripts here, because you can type in multiple functions. We're just going to deal with one. The one function we're working with is, do you want to do the 12x squared, or do you want to do the 3x squared?
3x squared.
Doesn't matter. In this case, doesn't matter. But we'll do the 3x squared minus 36 what? X plus 80. Now remember, we're not looking to graph it, right? I mean, it is going to be graphed, but we don't really care what the graph looks like. We only care about when does this graph equal to what? So once you type this in and you press graph, you're going to get this ridiculously huge line, right?
Can you go back? What happened? I don't know what happened.
Ooh. I can't press X to give
I
me
can't
data.
find X.
Oh.
Oh, it's the XT. And it's
Also,
not
no,
Y.
don't put it in here. Remember, I told you, don't put it in
No, I
here.
know, and then I realized, okay.
Oh, so
See,
it's
I
not-
pressed that, and then I don't know what I did, and then it went like.
Oh, there you go. That's how
Okay.
you clear it out.
Wait, it's not. Oh my god.
Oh yeah. Okay. Actually, this is actually kind of important. So these calculators are shared between BC as well. BC learns different modes. So if you ever turn on your calculator and when you press the Y button and you don't see the letter Y there, you see like the letter R, or you see the theta, or you see some other symbol that's not Y, you're gonna need to reset the calculator. Oh my.
How do I do that?
So let me show you that. Actually, that's something that you need to know how to do. So real quick. Real quick. No, it has not reset yet. So do it with me, okay? Actually, let's practice this together here. If your calculator is not yours and you're borrowing it, you should always reset the calculator first because you don't know what the person before did. Statistics also gets it messed up as well. So first things first, pay attention real quick. Let me show you, if you're not using your own calculator and you're borrowing someone else's calculator, let me show you how to reset a calculator. First things, okay? There's a button over here over the plus sign. Do you see how it says MEM?
Yeah.
That's the memory that you're going to need to reset. Now you see it's in blue, right? So what you want to do is press the second button, the blue button on the top left, right? And then you're going to go down here to the plus sign, which is the memory. It'll take you to this menu. Do you see this menu?
Yeah.
The one that you want is the reset. You see it?
7.
Option 7. So when you do second that, you press 7, and it's going to ask you, what do you want to reset? You want to reset all of it, okay? All RAM. So it's option 1. Press enter, and it's going to say, reset RAM, no, or reset. Just go down to reset and press enter,
I broke it.
and it will reset it all.
Okay, it reset.
And then at that point, everything should be back to where you can type stuff in.
Is this like
That's
the
clear.
intro?
That's good.
Oh, I thought I broke it.
No, that's how we
Okay, yeah, I got
how we
the
clear
line.
everything. So now let's go.
Instructions on clear. My hand is in the microwave.
All right, so I got to retype this equation again. So let's retype it again. And then what's up, AJ?
Oh, that one you can't see.
Yeah. Let me type this in first, and then we can take a look at this graph, okay? So once you type this all in, press the graph button, and this will graph your function.
Let's go.
Which is the graph?
Not
Yeah.
the off screen.
Right, like top right. Oh, I'm so blind. Said quit.
Invalid dimensions. Did you not reset it when I told you to reset it?
Right.
Why is it not
You
graphing?
said it was
That's
ready to
the
go.
Right.
You told me it was fine.
All right, let me reset
Did you
it.
type
How
in
do I
the
zoom out?
function?
Yes.
Is
He
it
said,
plus
okay,
or
here you
minus?
go. Type it in now.
Loki, this is
It
cool.
should work.
Why
Oh,
isn't
it's
it graphing?
someone
Because
that's
you're-
clueless. No, that's not
you're
that's
lame.
not you.
It's the one Natalie gave me. It's all Natalie's fault.
come
We type
yours
it
is
in.
like that and mine's isn't?
Can I actually type it in?
My graph
Yeah.
isn't showing. Oh.
My graph is
is
like
You have to go to a window.
Wait, what is it?
And
Right.
change the
That's
X
good.
maximum to
So
a Y
look at-
maximum so you can.
This is why I don't really like calculators. They're like,
Okay, what?
Windows, the
I don't really like
they're like how parents feel
You
about
see
my
Y
phone.
max?
Mm-hmm.
Why do you
Why
even
does that
even
go
in
back?
20?
Change the min to
This
make
new
it
generation
Oh,
of the
okay.
technology.
Oh,
My
Right,
graph
right,
is not
right.
even showing that. What was those full dibble calculators where if you moved it a lot, like it wouldn't close easily?
That's what I'm gonna show you, but I keep getting asked for it.
That's a generation before, bro.
All right. So here's the thing. I don't really care what the overall graph looks like, but you can adjust the zoom to see what the graph looks like if you really wanted to. If you press the zoom button, there's like a bunch of buttons here. You can zoom in and zoom out. That's the basic one. Then you also have Z standard, which is what it defaults to, which is -10 to +10 on both the X and Y axis. There's also another one, which is
How do you move it over?
that move the graph.
Yeah, like how do you move it?
You can't just move it with the arrows. You have to go in there and adjust the window. So focus for a second. There's a lot that's going on.
Oh, I see. Okay.
All right, so right now, if you're just looking at this graph and you want to move things around, there's a button here that says window. And it defaults to -10 to +10 on the x-axis, -10 to +10 on the y-axis. You can change that, and you can move the graph around. I don't like doing it that way, but you can. If you press zoom, on the other hand, though, you can zoom in and zoom out, right? So I can go here and select zoom out, and it'll ask you where do you want to zoom out. You just move the cursor to wherever you want to, press enter, and it'll zoom out like that. Okay? But again, option 6 is Z standard. This is what it defaults to.
Wait,
Then-
can you show that again? How do you
The zoom button. There's a zoom button right there. And then
zoom out all the way.
and you can zoom out. You select zoom out. And then you move the cursor to where you want to zoom out from. You can zoom out from the center. You can zoom out from here. It doesn't really matter though. And I'll zoom out and it'll show it right here. Now here's the bigger part. You can also zoom in, right? Option 2. Zoom in. Where do you want to zoom in at? Let's say I want to zoom in where the vertex is. I'll move my cursor all the way down to the vertex. You see it? Press enter there. It should zoom in around the vertex. See that? So you can move in and out, zoom in and zoom out, and move the cursor to where you want to zoom in and zoom out. So press the zoom button. One more time. Let's say you messed up your graph by zooming in or zooming out too randomly of a spot, and you're like all over. Option 6, Z standard, is where it will default. It's like your home button. So when you press Z standard, it'll take you back to here.
Calculators make me feel old.
Now, hold on a second. This one's, I think, the best feature on here on the zoom feature. If you scroll, they have this other feature if you go all the way down, which is zoom fit. Zoom fit is the calculator's ability to try to make the graph fit perfectly into the window.
But didn't it not?
It doesn't always work great. So I'm going to press it right now and let's see what it does.
This one doesn't work that well.
It works good.
Does it not?
They just press zoom out once.
Yeah, press zoom out
I missed
once.
the entire like.
Yeah.
Trust, look at
How do I
mine.
zoom out?
Press zoom on the top middle button. There should be a zoom button, and then select zoom out, and I'm going to zoom out one time and let's see what that looks like. No, that's not bad. That's not bad. It's weird. But anyways, let's go back. Can you guys all go back to the Z standard? Press zoom and just press number 6. Go back to Z standard. Go back to Z standard. You guys back to the standard?
Yeah.
We've gone on a pretty big sidetrack there, which is fine because you need to be able to play with this graph, and you need to understand like you're not going to break these calculators. There's no buttons you can there's no combination of buttons you can press where it's going to blow up. There's no combinations of buttons you can press where it'll stop calculating. You might get some errors because you might have changed some options, but then all you got to do is go back to memory and just reset it.
Oh, okay.
Right? So let's say you change some settings, you're like, oh crap, my calculator is no longer calculating. Reset it, it'll be fine. Okay? Now, what's our ultimate goal for this problem here? We're trying to find out when does this function equal to 0. You see that? We're trying to find out when does this thing equal to 0. Graphically speaking, that's when the graph crosses the x-axis. Right? Do you see it? So what we could do is try to move our cursor over to where it looks like it's crossing, but that's not very accurate. You see that? Like it's about like 2 points. Does that look like 2.7?
It's
2.9?
2.954.
Or is it 3.1? You could zoom in. Not the best idea either. Check this out. If you look closely, those menu buttons on the top there was window, there's zoom, and then there's trace. You see trace?
Yeah.
You can click trace, and when you click trace, it moves along. You can't see it right now, but once I get it onto the screen.
Only place it across the track.
You see how it's on the screen right now? So you can see it moving along the graph, but it's very hard to get it to hit exactly where I want it.
So would you have to
You could, again, but hold on and just listen to this part. Look right above trace. Do you see a word in blue?
Yeah. Table.
Where did I get the what? What options?
Oh, what'd you say? Help.
On the 5 buttons on the top. One of them says trace.
Oh. But it doesn't actually trace for me.
It's on there, it's just off the graph. What's the X value right now that you're tracing on?
2.27.
Keep going.
It doesn't even get on. It doesn't move. Oh.
Left and right.
Got it.
Yeah. All right, so here's the deal. You ready? Press the blue button second, and then press the trace button. So that way we'll go over to calculate. So what I did was I pressed this one right here second, and I'm going to go over here to trace. Brings up this menu, yeah? It's asking us to calculate some stuff, isn't it? I want to calculate where it equals to what? You see that right there? So yeah, option number 2 is going to calculate where the 0 is. I'm going to go ahead and press enter on that. And what happens now on the calculator? It shows you this thing that says left bound of your 0. So you have to put your cursor left of where you think the 0 is. So you can see where the 0 is. You see where it is? It's right here, yeah? When it says left bound, just press enter when it's a little bit to the left of it. So press enter. Watch what happens.
Oh my god, it gave you the line.
It marks it, and then what's the next thing you got to do?
right bound?
Right bound. So move the cursor to the right of it. So press to the right and move the cursor so it's on the right side of your 0. Doesn't matter if it's above or below. It just needs to be left and right. Okay. So it's on the right side. I'm going to press enter, and then it asks you, what is your guess? And you just try to get it as close as possible. You see how I can't get it exactly there? So I'll just put it as close as possible and press enter. So let me do that again. Let's repeat it again. Let's repeat this again, okay?
Does it have to be like right next to it when you do left bound?
No.
So it just has to be
Left of it and right of it. It calculates between the two and it sees where it crosses. So Anita, I know some of you are lost, so focus right here, right? Let's do it again. So right now I'm looking at the graph. I haven't done any calculations yet, yeah? I'm going to press second, and then I'm going to press trace. Takes us to this menu. I'm looking for the zeros of my graph. I go there and I press enter. And you see how it says right here on the bottom left right there, it says left bound.
Yeah.
You move the arrows, the left and right arrows. You see how my cursor is moving there? Do you see my screen?
Yeah.
You see how it's like off the screen right now? I just kind of move it until it shows up on my screen. You see that?
Yeah.
I want it to be to the left of where I want to see the 0 at. So where's my 0 at? It's right here. You see it? It's right there. If I go to the left of it, this is left bound. Oh no, you need your glasses, Anita. Come on. So do you see it?
Yes.
It is the left bound of it, yeah? When I go left bound of it, just press enter once. When you press enter once, what do you notice there? You see a little marking here?
Yeah.
It's marking the left side of the graph. Now it wants me to do what? Right bound. So I move it to the right just a little bit, right here. You see it blinking?
Yeah.
That's to the right of it. I press enter again. There's 2 little arrow markings now. I got an arrow marking on the left side and the right side, and in between is where the 0 is. The third option is to guess. And you move it as close as you can to there. Esther?
I got 2 lines with it.
Hold on. Let me.
So how do you do it?
So guess you just move it as close as you can. You're not going to be able to get it perfectly on where the 0 is, but that's my guess right there. Can you see it?
Like guess between the 2 arrows?
Yeah. And then press enter. And then that answer is your 0. That is exactly where it's crossing the x-axis at. Yeah, I just want you to guess. So just do that last part.
Wait.
Guess as close as you
So
can.
it's a
That's as
guess.
close as you can get. You just press enter. There's your answer.
Oh, why did it show me the line?
Yeah, because your calculator is more advanced than this old one. I
Oh.
It kind of shows you like the line of the
Yeah.
left bound and the line of the right bound. If you made it further apart, you can actually see it.
Wait, Mr. Hoppy. I have a question.
Yes.
So, it's like this, right?
Okay. My bad. Here's when I turn it on.
32 on there.
Oh, mine is messed up. I got it.
And then guess, we're still left. No, no. A little bit closer to zero.
Yeah, right.
You want the lemon one or
It's
the
okay, it's not on.
You know when you just stretch and then
That's your zero.
No, it's still not.
Yeah, 2 point. Nah, don't round it like that.
Oh, wait, I forgot that.
So what's my answer? Well, hold on. Let me write down this answer first. What's this answer? 2 point what? X is equal to 2.94. How many zeros? How many decimal places should we go? 3. So then it'd be 2.945.
4. Oh. Yeah, you have to do that. 5.
Approximately, right? Well, would you be wrong if you wrote down 2.944? No, not in AP Calculus. Rounding does matter, by the way. Rounding does matter, and rounding it, like, dependent on your significant figure, depends on your class. You go to chemistry, you go to physics, they usually want 3 sig figs. 3 decimals.
We did that in like chemistry and I felt
In,
like that was my favorite.
in calculus, they're okay if you just truncate the number, meaning you just cut off what you see. You don't have to round. So if they say go to 3 decimal places, 2.944 is perfectly acceptable, and so is 2.945. So if you want to round it correctly. If you don't want to round it, just truncate it. Just cut it, right? If it's too long, you need to cut it. All right. Yeah, there you go. Someone had to know that song. All right. Can you guys try finding the other x-intercept?
9.055.
Now, everyone else try and see if you get that same answer. Practice. Practice what we just did. Find the 0 for the next one over. And the next one over is over here. So do the same thing. Second, calculate. And really, you can't click and hold on this thing? You guys can. My emulator can't.
We can click and hold.
Apparently.
Oh, that's dope.
Isn't that so much better? I'm over here clicking my...
With the guess, we could just,
That's-
we do the one closest to it.
Yeah, and it doesn't have to be perfect. It will know. I think the more important part is the left bound and the right bound. So what do you get as your answer for the other one?
1e minus 11.
The x value.
Oh!
The x value. The 1e minus 11 is very close to 0.
The bound?
That's fine.
I got an error.
I'm lost.
Oh, it is? Oh, yeah, it's way.
There. So just look at the numbers.
Sorry, I don't know why
So
I'm
it,
today.
you weren't able to see it because
Oh,
it was like negative 100.
Oh, okay, thank you. Oh, sorry.
Mine keeps saying check for invalid.
Listen, I mean,
We're still struggling.
I get an error.
Okay.
How do you go back?
See, I got an error.
Error?
Yeah.
Oh, you have to go up.
Check for valid bound. Right bound is less than left bound. Uh-oh, the bounds are off. Oh.
Yeah, she's this.
Let's go second trace.
know.
Go to 0. Left bound needs to be on this side. Right bound needs
Okay,
to be
wait.
on that side. And then the
Why
guess
is
is
it
the
left and
other
right
way.
is right?
Do you remember that?
Are you talking in terms of X or Y?
Left is the 0. Left of where it crosses the x-axis. So this is
Oh,
this
now
side.
like
so
that.
I-
Wait, it's left of the 0?
That's what I did.
Okay, got it.
Towards the left, right?
We're trying to do left, which is the right. The hand you write with is
So
your
how-
left.
This is my right and which is
Can I get the guess?
I got it.
Okay, perfect. Hit enter and let's see if he gets it.
I'm smart.
Keep on.
You know, I think those lines are actually making it worse for some of you.
I keep on accidentally pressing clear instead of enter.
That's always
Sneaky
fun.
link. Sneaky link.
Look, I'm like constantly pressing okay.
That is just not sneaky link.
All right. So,
Sorry,
I didn't get to check these back. How are you guys doing? It feels bad. I was forgetting about all.
Wow.
This is painful.
Yeah, so you get 9.
Bush like.
9.05?
Oh, you know at the end of
Yes.
it?
Is that what you got?
Bro, he literally was like,
Oh, you haven't done it yet?
so he went,
Wait, yes, 9.
he grabbed
Did you also get 9?
I was like, actually, that was at the end
trying to come
Just
to a
kidding.
different line. Like, you know how there's y1, y2?
Okay.
Shut up.
All right. So come back over here. Let's see here. We got one of the answers right here, and then the other one was x is equal to 9 point what?
Go back to your seat. There you go.
9.0.
5,
6, whichever one you want to go with.
Huh?
Now,
No.
remember, look at our domain. What can we actually cut?
8.
So what can I say about this 9 value?
It's not.
It's a critical point, but it's not within our domain. It's something that we can't physically do. I can't cut 9 inches off of this box because that will no longer be a box, right? It'll just be folded cardboard, right? I can't include that one. It's outside of my domain. So that answer doesn't work for us because if I look at this shape, if I cut 9 inches off of this thing that's 16 inches long, it goes off, right? So this is the only possible critical point that we're going to focus on right here. I need to double check that this is going to be a maximum, right? So I'm going to go ahead and make myself an interval, right? So 2.945 is my interval that I'm going to cut around. So it needs to go from 0 to that number, 945-ish. And then I'm going to go from 2.945 to what? Not infinity,
No, to 8.
to 8.
That's the double.
That's your domain. I can't cut any further. I just need to see the signs of
So
this.
wait, question.
Yes.
Sorry to interrupt you,
Mhm.
but just to understand, why is our domain?
Oh, so why is our domain only up to 8?
Yeah. I just want to make sure.
You're okay with the 0 part though, right?
Yes.
Okay. It's up to 8 because if I were to cut more than 8, you see this side that only has 16 inches to give?
Mm-hmm.
If I cut 8 inches on this side, and I cut 8 inches on this side,
You're cutting everything off.
Oh.
there's nothing to fold anymore,
I see.
right? So it just becomes folded in half. So I can't cut 8 or more, right?
Oh, okay.
What's up?
Why don't we just guess and cut? Bam.
Well, here's the thing.
So
Your
we have
guess,
one sheet of cardboard.
you know what the answer is for this
Honestly,
cardboard
that's what I
cut?
would do.
It's 2.9 to give you the maximum volume. Are you going to guess 2.9 as you're cutting?
Just
I'll get really close.
put 3. Just
Yeah, 3 will get you pretty close,
That's like
but it won't
3.
get you the max.
close enough.
It's
Like,
close. en-
it's the max I could do mentally.
It's okay
It's-
to do
so
an,
here's- so-
like rounding.
If you're
Consider
doing this
yourself.
as your own project, yeah, I agree. You round to 3, you lose off on a couple of like cubic inches, right? Because it's just your own project and you have something for yourself. If you're talking on a large scale of a business corporation and you're losing out, let's say you're losing out a very small amount, like half a cubic inch per product, and you're shipping out millions of products, you're essentially losing out on
Fine.
hundreds of thousands of spaces that you could be doing, right?
See, but if
How are you gonna combat that?
no, okay,
As
like
long as
let's
it's
say
not
you're
really.
like you have to like do like shampoo or something like in a box.
I'm getting so tired.
Yeah.
One of those
I would
won't do
definitely
anything. And
quit.
plus you'll sell more
If I had
per
to figure
bolt.
out cubic
Well, that's the
inches,
thing. So
I
that's
would
just
quit.
shipping that. So you don't really care about that. But there are companies that do want maximum volume for their materials that they're dealing with, right? So that's for shipping.
Whoa, whoa, wait,
Now I
right?
know what type of
Wait.
business owner you got.
Wait,
Yeah. So here's the thing. Like, let's say we were trying to ship.
I'm trying to scam people, get money.
Here. No, that's the thing. That's fine. Then you want the critical point to be a minimum, right?
Well,
And
yeah,
again, if you're trying to
almost
scam people,
too.
you want the most that you can scam out of people. You wouldn't be like, okay, that's close enough. You want to scam the most.
Whose 6 inch are you guys?
Other way we can go is a very grim way, right? If you're trying to cut something out that stores the maximum volume of gas, let's say, you don't want to lose out on those little pieces because then you're not going to get as much gas in that vehicle. You want to have the most
See,
in
but
there.
like shipping two is not a big of a deal, but getting shipment, that's when it's a big deal.
They
Well,
we
you
have
have
something
something
around
around
off
off
that
that
much.
All right.
Moving on.
All right.
Consider.
Focus. Let's go back over here.
Right.
I'm plugging this into the derivative. I'm plugging this into the derivative to see if this is positive or negative, right? You can do this derivative right here, or you can do this derivative right here. I'm going to do it the smaller one, so it's a little bit easier to deal with. So it's going to be 3 times 1 squared minus 36 times 1 plus 80. This is going to be positive 3 minus 36 plus 80. This is clearly positive, right? Clearly positive. And when the derivative is positive, what do we know about the original function?
It increases.
What is increasing? The volume.
The
The original volume, right? Not the derivative, but the original volume is increasing at this point. Now, let's do the same thing for 3, which is on this interval. It's going to be 3 times 3 squared minus 36 times 3 plus 80. Sadly, this is not factored, so this one I actually have to do some of the calculations because I don't know this off the top of my head.
9 times 3 is 26.
27.
27.
Minus 36 times 3, which is?
That's gonna be more than 27.
Yeah, that's right. That's 108. 108
Plus 80.
plus 80.
It's negative.
Negative, yeah.
Barely, but still negative
By what?
by 1. So V is decreasing on this interval.
I love how Steven just knows the answer, so he doesn't
So
want to.
since this is going from increasing to decreasing, this is a relative max.
Relative max.
Yeah, it's a max. We can just say it's a max, but yeah, it's a max. So what do I need to cut this dimension of these little corners at? The dimensions of my square that I'm cutting out right here need to be what by what? 2.945.
See, but if you're doing like a project, like if it's like a personal project, you're probably just gonna do the three
Yes,
inches.
yes.
Because you can't
No,
really.
no, no.
See, what I would do.
See, look, you're arguing the same point that she's saying. I already said that.
No, do that.
You are the same. Just to tilt you a little further. But look, I'm telling you, we don't care for max and mins for our own personal. We don't care for our own personal ones. But if you're trying to do this for a company, which is a big deal, every company will sometimes want to max something or want to min something. And that's called optimizing. You want to optimize it. Yo, I'm like in the middle of saying a sentence. Like, you gotta get used to like not talking while I'm talking. It's so frustrating sometimes. But all of you are doing it. I don't need to just call you out. But there's a good chunk of you that need to stop talking when I'm talking. It's just weird. I like that you will feel comfortable to do it, but it's really hard to like focus already. Does that make sense? Steven, you had your hand up for a second. What were you trying to ask?
That's the x for height.
Yeah, the height for this one is going to be 2.945, but that's not what they're asking for. They're just asking for the dimensions of the square. So the square that we cut out
So
is 2.945 by 2.945.
for visual to show it.
Yeah, well, we needed it because we want to calculate the maximum volume, but they didn't ask us what is the maximum volume to get. If they do want the maximum volume, we would then plug in this 2.945 in wherever we see x's here and calculate the volume. Does that make sense? Jasmine?
Okay, so like maybe I probably like not that I did it, but could we have just done like set the 16 minus 2x and 20 minus 2x to 0?
No, sadly, because those parts are used to calculate the lengths and the widths. And if you set that equal to 0, that's just going to tell you that what should x be so that you don't have a length or you don't have a width. So when you solve that, by the way, 16 minus 2x equals to 0, you're going to get x equals to 8. And what happens there? If x is equal to 8, there's no width. And that's what it is when you set that equal to 0. You're saying, hey, what does x need to be so that there is no width to this box? And that's what you're finding.
What would this look like that would this be like an MCQ or
This will be a free response question for sure. But just a heads up, free response questions don't really deal with optimization problems too much. They deal with the next section that we're going to do, which is also have to deal with rates, but it's called related rates. We're not going to have time for that today. But what I do want you to try now is something that's not as crazy as like a drawing. Optimizing these problems can be as simple as just like a simple like algebra 1 problem. You've done this before, and you probably did this using system of equations. I'm going to show you right now you can do this with calculus instead of system of equations. Which one's actually easier? You're probably going to say guess and check is probably the easiest way. But check this out, okay? Let's go with this next one right here. Let's say I was looking to find two numbers. That's very tiny, isn't it?
We're going on to the next problem now.
Yeah, let's go on to the next problem.
That took us a whole hour.
Yeah, and, but that's okay. That's okay. It is. This one, you want to try it on your own?
No.
Well, can you at least
Option two.
can you at least can you at least see the question first? Find two numbers whose sum is 10, for which the sum of their squares is a minimum.
The fact that you come with these off the top of your head is really concerning.
Oh, it's not the top of my head. This is an older problem that we've done, or I've done. And when I say I mean not done. And when I say this, I don't say that. But stuff and whatnot.
It still amazes me how Nafi literally improvises, like, sometimes his class.
Yeah.
He has a skeleton. He has a real skeleton, but he improvises a lot.
We just sit here and watch him like it's like a genius. He's like, oh no, that's not it. Let me just reprogram this real quick.
Yeah.
What's up?
Okay, so two numbers are equal to 10
And their sum of their squares
so like
is a
the
minimum.
square has to be less than,
Has to be the smallest possible.
Not even.
has to be as small as that.
So, freaking out a little bit. This one, you can see that we can't draw a picture, right? There's no box, there's no river, there's no nothing. But we can get some representation, right? One of the skills that you're gonna need to learn, that you're supposed to be learning right now, is the skill of making things abstract. Because honestly, you're probably sitting there going like, what are numbers that add up to 10? You probably have some in your mind.
5 and 2.
That's not 10. Yeah, 4 and 6, 5 and 5, 7 and 3, and all that good stuff, yeah? But the second part is the part that makes this part interesting, right? The second part is, let's take 5 and 5, for example. 5 and 5 add up to 10, but they're squares. What does that make? 5 squared is 25, plus the other squared, which is also 25.
120.
That will give you a sum of 50.
50.
Now, is that the smallest sum you can get of the squares? I don't know, but we could just try another one. Let's try 6 and 4.
That's
6,
16
no,
times
6,
36.
6 plus 4 would make 10. Pause there.
Oh, okay, then square.
Then we would square the individual numbers, then add those together.
36 plus 14 equals 50.
16 plus 36.
50.
Yeah. Yeah. 6 squared is 36.
Alright.
4
Here.
squared is 16.
So the first thing we were supposed to do is find numbers that sum up to 10. Okay? Second part you're supposed to do was to square those numbers and see what does that equal to. In this case, this equaled to 50, didn't it? Right? It was 25 plus 25 equals 50. Another example you guys told me was 4 plus 6, and that also equals to 10, doesn't it? So that meets the first condition. Second condition then is 4 squared plus 6 squared.
16 plus 36.
So 16 plus 36,
Plus 50.
52.
52.
52. Wait, what? Oh, because it's not 14. You're right.
So this is clearly not the minimum outcome, is it? Because this is bigger than this one. But do I know that this is the minimum? I have no idea if that's the minimum.
Oh, do the chart.
Yeah, you can. You can. But man, that's going to take forever. Also, that doesn't include the decimal values. Because you could also argue
true.
4.9 plus 5.1 also works, doesn't it?
Are two-
And I don't want to square this because I'm lazy. But whatever that is and whatever you get, I don't know if that's going to be the minimum or not. So what you want to do is cover all your bases. You want to set an equation up so you can prove that it's the minimum. And you can prove it's the minimum because in calculus, the minimum occurs where?
At the minimum.
Yes, at the minimum, but
At the
The lowest part.
at
The lowest.
yeah, that's what a minimum is. But
The lowest
think of it in
point.
terms of calculus.
When it decreases,
Yeah, when you have a critical point.
Oh,
Yeah.
yeah.
That's it.
That was our next
What
answer.
is this then? That's what I'm
That's a
saying.
line.
Exactly.
What does that
That was
mean?
our next answer.
Use calculus terms, please. Don't just say like this or that, right? Minimum is the lowest point. Yeah, that's something you should know before this class. But minimums occur at critical points. And that's specifically when a critical point, when a derivative is changing from negative to positive. Right? Negative to positive. That could just be a maximum. It happens there at a maximum too.
No, but it's like the bottom. Like it is like
Well, we
the-
don't know that. You just do this. It's the bottom. Or this is the bottom.
Oh, that's
We
that
don't know.
bottom.
So, let's go ahead and try this out. How do we abstract this? I need to pick what at the beginning there? I need to pick two numbers, right? But let's say we don't know what those numbers are. What can I use to replace those numbers? X as one number. And what? Y. So x plus y should equal to what? 10. That's an equation we have, yeah? We're then looking to see a function that will give us the minimum number. That function is going to be x squared plus what? Y squared. I want this to give me the smallest possible number. Let's call this function the, what do you want to name this function?
1.
No, don't name it a letter.
Number?
That's not a letter.
I mean a number. Don't name it a number. You want it a letter.
Just put A and B.
We can go A. Just go A, right? We can go B. We can go S. You can go squares. Right? Like earlier what letter do we use up here? We use V for the volume, right? This is going to be A for the sum of their squares, right? A is equal to the sum of their squares. Okay? Sum of their squares. Whew.
Wait, so that whole example should I not already write down?
Which one? No, yeah, you can have them. It's just nice to see it. I took it off because I don't have enough space. But
We
now,
have infinite amount of space.
here we go. To fit on the screen. Fit on the screen and still write. All right, so I'm looking to minimize this function right here, which means I need to take the derivative of this function, but how many variables do I have here? I have two. I have an x and I have a y, and that's kind of, it's going to be a little bit annoying, right? That's why we have this equation, don't we? Right? So I can solve for one of them. Which one do you want to solve for? X or y? Solve for x? We can do that. X is going to equal to 10 minus what? 10. So I can replace wherever I see an x with 10 minus y. You see it? Then we're going to get here, this is going to be 10 minus y squared, because I'm just substituting, right? Plus what? Is equal to a. This is my new function as a form of just one of the variables, which kind of makes sense, because if x was equal to 3, that kind of forces y to be 7, doesn't it? If x was equal to 7, that forces y to be 3, because the overall rule is what? It needs to equal to 10.
I know the. Wait, can you explain
Which part?
how y squared got defined?
This y squared? Or this y squared?
The third, the one you want.
This y squared? Which one are you?
Just the equation on the bottom.
This whole equation?
Your x is 10 minus y, and your x right there is squared. So you're replacing the x with the 10 minus
Oh, so,
y,
oh,
and then
okay.
the parentheses are the square.
So, we get x minus, if x equals 10 minus y, then we plug it into the second equation.
For the x, that's right. I need to take the derivative of this. You can just chain rule and do it all the way across. You could simplify and then do the derivative. It's up to you. You get to choose your poison. I, in my olden days, would FOIL this out and simplify and then do the derivative. I, as my personal, like today, present day, would probably just do the derivative there using chain rule. It's up to you which one you want to do. I'm going to go back and just feel nostalgic and simplify this out. I'm going to FOIL this out. So I'm going to, be sure you FOIL carefully, please. Right? This will be 10 minus 20y plus y squared if you FOIL that. Right. Wait.
Yeah.
100 minus 20y plus y squared. I was going to say 100. I just forgot that extra 0. Plus y squared. This is going to equal to the sum of their squares. Combined like terms, this is going to be 2y squared minus 20y plus 100. Is that okay? That's the cleaned up version of that formula. So meaning if I know what y is equal to, I know what the sum of their squares is going to equal to, is this formula right here. I need to find the minimum of this, don't I? Not yet. Do the derivative, right? Do the derivative, and we end up with 4y minus 20. Yes, Anita?
So when you're doing this, you're also solving for y?
Not yet. I'm not solving for y yet. I'm going to solve for y when I get it to the derivative and get the derivative equal to 0 because I'm looking for the critical value. Right? So here's my derivative. What's my critical point? 4y minus 20. What does that need to equal to?
10.
Critical point. What does your derivative need to equal to?
0.
0.
Sorry. I'm so sorry. I gave you the answer.
Yeah, you're giving the answer. So when you move this over, you get 4y is equal to 20, or in other words, y is equal to what?
5.
I don't know if that is going to be the minimum or not. What we should do is test around it, right? I should test numbers that are going to go from, I believe, 0 to 5, and then the other one needs to go from 5 to 10, because when you talk about sums, right? If you want to be specific, it technically could go from negative infinity to infinity, because you could do numbers like negative 20 and positive 30. I go from 0 to 10. But if you really wanted to, you wouldn't be wrong if you did negative infinity to positive infinity in this case, because it's technically true. You could technically have, like I said, negative 20 plus positive 30, and you will have a sum that makes 10. But anyways, let's pick the number here from 0 to 5. I'm going to go with like 1. Yeah? And over here from 5 to 10, I'm going to go with like 6. All right, just nice small numbers. Plug it into the derivative and see what we get. 4 times 1 minus 20, is that positive or negative?
Positive. What?
That's negative.
Sorry.
6 is going to be 4 times 6 minus 20. That's going to be what?
Positive.
So this is clearly decreasing, right? The function is decreasing from here to here, right, on this interval. And then the function is increasing from here to here.
So this is a local min.
Yes. Which is what we want, isn't it?
Yeah.
So this right here, y is equal to 5, is a minimum for our whole thing up here. So what's my answer? What are two numbers whose sum is equal to 10, but their sum of their squares is equal to a minimum? I want y equals to 5, which tells me then x has to equal to what?
5.
And that's our answer.
Wow.
If it was not as simple to solve, would you just plug it back in the first equation?
What do you mean as simple as to solve?
Because it's 5, so we know that, like, if you just subtract it, it'd be 5.
Yeah, yeah.
So could we also just like plug in y equals 5 and then just solve for x from there?
Yeah, yeah, into the x plus y equals 10 equation. Yeah, yeah, I mean, it's the same thing. If you plugged it into the equation I have boxed up here and you plugged it into this equation, it's the same thing algebraically. You just one's solved for already. But yeah, hope that answers. Anita?
Adding on to Stephen's question, like, if it was a bigger number, you would have to also solve for y, right? Define.
You mean for x?
Weren't we solving for x?
No, we were solving for y the whole time.
That's what I asked in the beginning. Wait, what?
Oh,
Wait.
hold up.
Didn't you have to do?
So here's the thing. I solved for x
Yeah.
to substitute. Once I substituted, there's no more x's.
Oh, so now you don't.
So now I'm solving for y. Yeah, yeah. So does that make sense? Yeah. Don't overthink that. When you substitute one variable out, that variable is gone, right? So what you're solving for is whatever is left over. And then you got to go back and see what you got for the other variable. Does that make sense? Or no? Yeah? Maybe? Okay. This homework I'm going to put up right now because this is going to take a little bit more time than the other homeworks.